Assalamualaikum and hello everyone, welcome to our video presentation. We are group 3 and today we will be demonstrating how a test sieve stack is used to analyze particle size distribution in wheat flour. So without further ado, let's get started.
Before setting up the machine, a lab coat and safety shoes are used to ensure safety during the operation of the test sieve stack.
Before we begin, let's take a look at the main equipment used in this experiment. This is the test sieve stack and sieve shaker machine, which helps separate particles according to their size through vibration. Here we have our sample, which is wheat flour. This sample will be placed into the sieve stack and analyzed to determine its particle size distribution.
Next, the sieves are arranged to form a sieve stack. The sieves are assembled according to mesh size, with the largest mesh size placed at the top and the smallest mesh size at the bottom. This arrangement allows particles of different size to be separated effectively during sieving. After the sieves are arranged correctly, the top cover is placed. The support rods are then secured and the hand wheel are tight to hold the sieve stack firmly in place. Proper sieve tightening is an important operating parameter because it prevents sample loss and ensures accurate particle size separation during vibration. Finally, the sieve stack is checked to ensure that all components are secure and ready for operation.
Next, I will explain the operation of the sieve shaker. First, we prepare a stack of testing sieves with different mesh sizes. Each sieve has a different opening to separate particles according to their size. The sieves are arranged from the largest opening at the top to the smallest at the bottom. This is important because it allows the particles to be separated gradually and prevents the finest sieves from becoming clogged. Next, the sample is placed on the top sieve and the sieve stack is secured onto the sieve shaker. The machine is then operated for a fixed duration, usually around 10 minutes. During this process, the shaker vibrates continuously, allowing the particles to move across the mesh and pass through the appropriate sieve according to their size. This produces more accurate and consistent results than manual sieving. After the test is completed, the material retained on each sieve is collected and weighed. The weight retained on each sieve is used to determine the particle size distribution. This analysis is important because it helps us evaluate the uniformity of the sample and ensures it meets the required quality specification.
After the sieving process was completed, the sieve shaker was switched off using the side power button. The screw on the vertical rod was loosened and the lid was carefully removed. The sieve stack was then lifted using the bottom pan and transferred to the weighing station. At the weighing station, a sheet of paper was placed on the balance and the balance was stirred before weighing. The sieves were then checked one by one, starting with the largest sieve size of 4 ml. No flour was retained on the 4 ml sieve, as well as on the 2 ml and 1.4 ml sieve. Only a very small amount of flour was found on the 1 ml sieve. The largest amount of flour was retained on the 500 micrometer sieve with a weight of 123 grams. Then the 300 micrometer sieve retained 5.4 grams of flour. The 212 micrometer sieve retained 48.8 grams. Also, the pan below the 212 micrometer sieve collected 23 grams of flour that passed through all the sieve. Based on the result, most wheat flour particles were retained on the 500 micrometer sieve, indicating that the sample mainly consisted of medium and fine particles. No material was found on the largest sieve, showing a very few coarse particles. The flour collected on the 212 micrometer sieve and in the pan confirmed that the presence of fine particles. Overall, the sieve analysis showed that the wheat flour sample was mainly composed of fine particles.